All right. Hello and welcome, everyone. My name is Rick Frage. I'm the sales manager at SF Tech. On behalf of our team, I'd like to welcome you all to our first webinar of the year about our alkali resistant glass fiber reinforcement concrete. It will be presented by my colleague, Dr. Mohammed Al-Adawi. This webinar will take about 30 minutes, plus we will have 10 minutes towards the end of Q&A. So if you have any questions, please, during the webinar, please feel free to use um, the Q&A icon. I believe it should be either on top or at the bottom of your screen. And we will try to address as many questions as we can towards the end. I'd like to take a couple of minutes, of course, to introduce to you my colleague, Dr. Mohammed. So Dr. Mohammed received his Bachelor's of Science and then Master's of Science in Civil Engineering from Al Halwan University in Cairo, Egypt, after which he worked as a structural engineer, he did a lot of seismic analysis for several tall buildings. He then came to Canada after being admitted to the PhD program at the Department of Civil Engineering at the University of Sherbrooke in Quebec, where he did his research on structural design, analysis, and testing of concrete structures reinforced with FRP, fiber reinforced polymers. He is now a METAX postdoctoral fellow at the University of Sherbrooke. He joined SF Tech back in June 2020. He worked with us on several different designs, whether structural or non-structural elements. Who are we, SF Tech? We are associated with Shandong Safety Industries. It's a Shandong manufacturer of FRP rebar. That's their main focus. We are the exclusive representatives of all their products everywhere in the world except for the Asian market. And we are developing strategic partnerships in Canada and in North America in general, Latin America, Europe, Africa, and Australia, whether it's distributors or engineering firms. And our focus is to support our distributors by targeting national and international engineering firms to help them with the design of their structure with fiber reinforced polymers. Our main focus is parking facilities, parking garages, water treatment plants, and retaining walls. However, we have been involved with different other projects, including bridges, tower communication bases, and windmills, basically almost everything. So our goal, our focus is to develop the FRP market and increase the awareness of it as a non-corrosive alternative to steel. So what is FRP? As I just mentioned last thing, it's an alternative to steel rebar. It's basically a non-corrosive alternative, which makes it superior in a lot of different aspects. It's basically made of fibers of different materials, and that fiber is reinforced with a polymer, as we can see on the picture to the left. There are three main types, or actually four main types of fibers. We have the glass, the basalt, the aramid, and the carbon. The basalt is not in the curve, but we can see the three main ones on the curve and how they compare with steel. The main difference we can see, there are two main differences between fiberglass and steel, that they are at least 2 to 3 times stronger, has higher tensile strength than steel, but they all are linear up to failure, meaning they don't show any ductility like steel does. And that eventually affects the design. So the carbon being the most strong, then we have the aramid, then we have the glass. And basically the glass is the most popular one because it's already 2 or 3 times stronger than steel. But in terms of budget, it's definitely the cheapest between the three different fibers that we are discussing now. Regarding our products, we focus glass fiber reinforced bars, but we also do different types and shapes. We have bent bars, spirals, squares, everything you need. Also, as you can see on the right side of the screen, we are focusing also on FRP connectors for sandwich panels. Those are shear connectors, and they are getting a lot of attention from precasters in North America. We also introduced two new products. To your left is the carbon fiber sheets. They are mainly used for restorations. And to the right is the AR or Alkali alkali resistant glass fiber, which Dr. Muhammad will be digging deeper and explaining more about this particular product. So just to sum up the advantages of FRP over conventional steel, you can expect a longer service life. It has an improved durability in harsh marine environments. As I said just moments ago, the fact that it is non-corrosive makes it very fit for harsh environment, including marine pipelines, water treatment facilities. As we saw in the curve before, it has a greater tensile strength than steel. However, and that's a big advantage, it weighs about 4 times lighter than steel. We have seen, if you want to check our YouTube channel, we have a testimony from a general contractor that explains how does that affect their productivity on the job site in terms of delivery of bars to where they have to be installed, to the actual installation, and the fact that they could have continued working during rainy days, while with steel they would have stopped because of the lightning and the conductivity of steel. So having said all this, it's very fit for harsh chemical environments like pipelines, and the fact that it's neutral to electromagnetic disturbances first contributes to the productivity on the job site, but most importantly makes it a good alternative for niche projects like MRI room in hospitals, military applications, airports, and so on. And last but not least, it is definitely a more ecological product than steel. So if you're building, say, a green building or so on, you can get lead points because of the fact that our product is at least 95% of the glass used is post-consumer recycled glass. Also, the embodied energy needed to produce fiberglass bars is a lot lesser than mining steel and shaping it. So that's it. That's a little bit about us and our products. I would let Dr. Muhammad dig a little bit deeper in the AR glass fiber.
Today in my presentation, I will present one of our FRB product, which is Alkali Resistant Glass Fiber Reinforcement. Through my presentation and through these outlines, I will give an overview about Alkali Resistant Glass Fiber and its properties, advantage, and effect on the concrete behavior. Also showing different concrete applications reinforced with this kind of fiber. As it's known, concrete is one of the most used construction material in the world. That's due to concrete low cost and easy availability of its components. Also, it provides an excellent strength properties in compression. However, due to its low tensile strength, concrete easily crack in tension, flexure, and shear, and also due to different environmental factors such as thermal crack and shrinkage crack. Cracks formation adversely affect on the concrete durability. The appearance of the crack shortens the corrosion initiation time of the reinforcing steel bars. Also, it accelerates the propagation of the corrosion during service life. That will lead to a significant damage and loss of load carrying capacity for the structure building. Therefore, recently the non-corrosive natural with high strength of FRP reinforcing bar have been used in a wide range of construction applications as internal reinforcement in concrete members, such as bridge deck slabs, bridge barriers, bridge diaphragm walls, tunnel segment, water treatment, and marine structure. Another concrete technology that could improve the mechanical properties of the conventional concrete is using natural fiber reinforcement. According to the main standards for fiber reinforced concrete, there are 4 main categories for fibers, like steel fiber, glass fiber, synthetic fiber, and natural fiber. The addition of small discrete and uniformly distributed fibers in concrete enhances its durability, static and dynamic properties, and also reduce the concrete cracks. Alkali resistant glass fiber, our product is one of this fiber reinforcement. Our company, Safetec, advises its client in North America to use it in order to improve and enhance the concrete behavior. Alkali resistant glass fibers are a short, discrete fibers that should be uniformly distributed and randomly oriented into the concrete to improve its properties. One of the main advantage of the alkali resistant glass fiber is maintaining its strength and toughness without deterioration in the long-term effects. Alkali-resistant glass fiber is easy to mix with the other concrete component, with a volumetric ratio ranged from 0.2, 0.25 to 4%, based on the fiber length and diameter. However, the mixing process is very important to have a uniform fiber dispersion in the concrete. The preparation of alkali-resistant glass fiber reinforcement in a concrete mix requires careful consideration. There are many ways to add a glass fiber to the mix. For example, all the concrete components placed in the mixer in a layer, C cement, sand, glass, and also fiber. Then adding 2/3 of the water to the mixer and mix them for 3 minutes. After that, we can adding the remaining 1/3 of the water and mixing them again for 3 minutes more. Another way, by adding the glass fiber to the concrete mixing after we add the water in three equal quantities and mixing them for 4 to 5 minutes to make sure all the fiber is distributed in the concrete mix. Alkali resistant glass fiber also improve surface integrity and homogeneity of the concrete. Therefore, it reduces the concrete bleeding. On the other hand, this kind of reinforcement improves the cohesion of the fresh concrete. Therefore, workability of the concrete should be taken into consideration during the cast. Alkali resistant glass fiber are differentiated by being relative inexpensive, light in weight, and high tensile strength. It has an excellent mechanical properties comparing to the other material, where its elastic modulus ranged from 70 to 80 gigapascal. The tensile strengths ranged from 650 to 750 megapascal. Also, its elongation has reached up to 3.7%. It also has a low creep in the room temperature, and this kind of fiber are flexible and have a dimension of 12 to 20 millimeter in length and 14 to 18 micrometer in diameter. These excellent mechanical properties have a significant effect on the concrete behavior. Adding alkaline resistant glass fiber to concrete mix will improve the ability of the concrete to control and reduce the crack size resulting from early edge shrinkage of the concrete. Fiber also will act as internal support system so that tensile, flexure, impact, and shear strength of the concrete will be enhanced. It will develop resistance to explosive concrete spalling, and also it maintain homogeneity of the concrete mix. Therefore, the concrete toughness and abrasion resistance will be increased. Finally, it also improves the water resisting properties for the concrete. But it should be noted that glass fiber cannot replace the reinforcing steel or FRP bar in the structure application. Therefore, alkali resistant glass fiber reinforcement contributes to reducing the weight of the concrete element. It rising the service life of the concrete structure, improve the concrete durability, as well as it reducing the concrete permeability. So alkali resistant glass fibers reinforcement have shown a perfect potential to use in a many construction applications, such as concrete bridges, tunnel segment, concrete pavement, and marine structure. Another application of using alkali resistant glass fiber reinforced concrete is as a filling material for the structure masonry elements to enhance the overall composed action of the masonry structure. Several studies show that adding glass fiber to concrete effectively controls the cracking propagation in the masonry block, and also converting the failure of the walls of the masonry walls from occurring suddenly to be more gradual. This is a recent research on the using of the glass fiber reinforced concrete in masonry wall. Good and Ital at 2020 tested 36 full grouted half-scale masonry prism with a different short length of shaped alkali glass fiber with a different ratio. He concluded from his research that adding alkali glass fiber to grout enhances the crack control and post-cracking performance of the wall. Also, adding glass fibers to the grout mix will not affect on the compressive strength at the low fiber percent. Similarly, alkali resistant glass fiber could be employed in precast concrete pipes as alternative reinforcement. Several studies found that alkali resistant glass fiber reinforcement could hold the crack and prevent total collapse of the concrete pipe. The same technique was recommended to be applied for the concrete precast culvert and concrete precast vaults. And recently, the same technology was adapted to be employed for the 3D printed concrete construction. So in general, we can summarize that alkali-resistant glass fiber reinforcement have a significant effect on the concrete durability, fatigue resistant, and the flexure toughness. Also, it resisting and minimize the concrete cracks, as well as it improves the post-crack load carrying capacity for the reinforced concrete structure. For all of these reasons, our company Ceftec recommended this kind of fiber reinforcement to improve our client concrete quality in their project. And finally, this is a list of the standards and codes that provided all information, recommendations, and tested regarding this kind of fiber reinforcement in the concrete mix. And finally, thanks for all of you for your attention.
Thank you, Dr. Mohammed. I just want to mention that all the codes that were shown in the last slide. These ones are also on our website, www.sftech. That's sftec.com. You can have access to these codes. Anyway, thank you again, Dr. Mohammed.
Yes.
We have a few questions actually, if you have a few moments to
Yeah,
answer.
sure.
What is the effect of the glass fiber reinforcement on the concrete workability and on the segregation of the concrete?
At high fiber content, alkali resistant glass fiber reinforcement will enhance the fresh concrete cohesion and also interlock around aggregate particulars. So it reduces the concrete workability, but it's not too much. But if we need to have a flow concrete, we can add sometimes they recommended to add super plastizer admixture to facilitate the flow of the concrete during the casting. But it reduces the workability a little bit for the concrete, and
Okay.
that's for high content of the FRB.
The next question is, why does the AR glass fiber possess better durability in alkaline environment?
Because glass fibers component have a high content of zirconium. Zirconium is a component for the glass fiber, and this component protects the fiber from the alkaline attack of the cement mixture. So due to the component of the glass fiber.
So it's basically the component of the fibers
Yes,
themselves.
yeah. It's named zirconium.
What is the effect of the AR fibers on the concrete compressive strength and on its permeability?
For compressive strength, alkali resistant glass fiber had a significant effect on the tensile. But for the compressive strength, it has a marginal increase in the compressive strength of the concrete. I mean, it's increased the compressive strength with 5 to 10%, not like the tensile. It increased the tensile strength by 30 or 40% of its strength.
So
It has a marginal increase in the compressive strength, not too much. I mean, like 5 to 10% just only increase the compressive strength of the concrete.
okay, and that's why you would still need the reinforcing bars. You cannot
Exactly,
just
yes.
depend on the fibers as the only structural element in the mix. Could the pump pour like the concrete when it has the glass fiber? Does it affect the pump? Does it get stuck in the pump?
Yeah.
It's a very practical question, I guess. It's
Yeah,
a good question.
yeah. Actually, glass fiber, we can pump the concrete reinforced with a glass fiber. As I mentioned in the properties of the glass fiber differentiated by it's flexible, so we can easy pump the concrete reinforced with a glass fiber. For example, if we use a steel fiber, as you can see here, steel fiber. If we use a steel fiber in concrete, we will find some difficulty to pump this concrete. But glass fiber is more flexible than steel fiber. So it's easy to pump concrete with a glass fiber. Also, sometimes they use spray the concrete with a glass fiber. So we can pump and sometimes we can spray, but we need a shorter glass fiber.
How does the AR pull out resistance compared to bent or profiled steel reinforcement fibers? Thank you very much, Dr. Mohammed. I really appreciate your time. I want to mention to all of our clients that we are happy to announce that the products we will have the fiber bars mainly in Canada by next month. Westec Enterprises Limited has become a distributor in Saskatchewan, and will be happy to distribute the product to whoever needs. We also have Miltrade Building Material in Alberta, and we're also that is receiving also the products, hopefully also within a month or a little bit longer. We also are working with a couple of potential distributors here in Quebec. So we're hoping to be able to have the product in Quebec. So if you have any questions, inquiries, or projects, we definitely will be, for the most part, will be able to supply the product much faster now that we're going to have the product in Canada. So please do not hesitate to contact me. Again, I'm Rick Frage, and or if you have any technical questions, you can contact Dr. Mohammed or Dr. Ahmed. Also, some of you know him. Or contact me and we can give the work. to our experts to help you out with the conversions and the designs. Thank you everyone for joining us, and I hope we'll see you next webinar, which will be about. I will be presenting the next webinar to give a little bit of a business case for using FRP compared to steel, and how it compares financially rather than just technically. So hope to see you soon next webinar. Stay tuned to know exactly the dates and the time. Thank you very much, everyone, and have a wonderful day. Thanks, Dr. Mohammed.
Yeah, thank you so much. Thank you.